Hey, hello everybody, Mr. LaHaye here. Going to go over the Hess's Law problems that you were supposed to do for homework. I know there was some confusion about this on Wednesday, and due to the ice day, did not get a chance to go over this stuff before I was obviously going to be gone on Friday. So please watch this video, make changes if you did find your way through this and had some incorrect answers, or if you were completely baffled. Please really watch and try to learn from this so you can complete more problems today, because I have a few that I want you to try now. So again, the process with Hess's Law, I'm gonna do this as I go, but make sure that you follow these two rules that I taught you in class on Wednesday. But I'm just gonna kind of scream through these. Feel free to replay anything you need, you guys I'm going too quick on or anything like that, and catch it as you go. Okay, so again, with Hess's Law, we have a final reaction that's at the top, and then you have partial reactions that you're going to try to manipulate. So when you add everything together, they look like that. Okay, so I'm going to start with H2O2. Basically, on this example, we need two H2O2s, okay, on the reactant side. So you look at your partial reaction, and H2O2 shows up right here as a product, and I have one of it. Okay, so essentially what you need to do is take this reaction A. By the way, that's the only place H2O2 shows up. We're going to take reaction A, and we're going to flip the reactants and products, and we're going to multiply it by 2. So I get two H2O2s on the reactant side. Okay, so I'm going to rewrite reaction A down here where I have space, and multiply everything by 2 and flip everything. So I'm going to have 2 H2O2 liquid yields 2 H2 gas plus 2 O2 gas. All right, and then delta H, my enthalpy change, it needs to be doubled and it needs to be flipped. So it's going to become positive, and I need to do 187.9 times 2. So 375.8 is the new delta H. Positive 375.8 kilojoules. It becomes positive again because we flipped the reaction, and it doubled because I had to double everything in order to get two H2O2s. Okay, so now we can say H2O2 is in the correct spot. Good to go there. Next, I'll deal with H2O. I need two H2Os as a product. So I look at this first reaction, which it doesn't appear in there, and I've changed that to this reaction anyways. So I look at reaction B, and H2O, liquid right there, is on the correct side. Okay, it is a product. I needed it to be a product. The problem is I need two of it, and I only have one of it. So what I'm going to do is take this entire reaction B and multiply it by 2. So I'm going to rewrite equation B as 2 H2 gas plus 2 times a half is just 1 O2 gas yields 2 H2Os as a liquid. Okay, and again, if you do it to the reactions, you have to do it to the delta H. So I need to take negative 285.8 times 2, negative 571.6 kilojoules. Okay, at that point, now we're going to go look. So we've got two H2O2s in the place we want. Product side, 2 of them, we're good to go there. Now O2 appeared in both half reactions. And like I said on Wednesday, if something appears in both half reactions, you just ignore it. It's going to work itself out. So now what you're essentially going to do is treat this like a mathematical equation and add things down. But first, if something occurs on both sides of the arrow as a reactant and a product, you cancel it off. So for example, H2, I have it 2 of it as a reactant here and 2 H2s as a product here, so I can cancel that off. Okay. O2, I have 1 O2 as a reactant in reaction B, and I have 2 O2s here as a product. So this 1 will cancel off one of those, leaving you with just 1 O2 as a product. Okay. Everything that doesn't cancel, you bring down. So 2 H2 O2s liquid, nothing canceled with that. That's the only thing left on the reactant side. Yields 2 H2O liquid plus 1 O2. And then if you go back and compare that to where we want it to be, it's the exact same reaction. So that's how you check your work. Got the same thing. At that point, all you're going to do is add your enthalpies. So we're just going to take negative 571.6 and add 375.8 to it, and you get your total enthalpy change, delta H equals negative 195.8 kilojoules. which is now your answer. And you can say that this is an exothermic reaction because you have a delta or a negative delta H. Okay. Now, I'm not going to run through all of these because it'd be too long to watch. I'll do a couple more. I'll do two more, and then you can finish up whatever you did not already have done, if there was anything you didn't already have done. So I'll jump to number 2. Calculate the delta H for the formation of lead-4 chloride by the reaction of lead-2 chloride with chlorine. So this is your overall reaction right here, and we're going to use these to get them manipulated in that way. Now, it's really important to pay attention to solids and liquids because things look very similar. So keep that in mind. We'll start with PbCl2 as a solid. I need one of it on the reactant side. So I got to look for it, and here it is. The only place it appears is in reaction B as a product. So what I'm going to have to do is take this and flip reaction B. I have the correct amount. I need one, but I'm going to flip reaction B and make this PbCl2 solid yields Pb, lead, solid, plus Cl2, chlorine gas. Okay, so flip that reaction, and then I have to take my delta H, since we flipped the reaction, to make it a positive 359.4 kilojoules. And I can cross out the old reaction B. Okay, so PbCl2 is in place. All right, next I go to Cl2, but I see Cl2 in two different places. It's in both partial reactions, so I'm going to leave it alone. Go over to PbCl4. I need one of it as a product. Hey, look, I have one of it as a product. That's telling me that I can probably use reaction A as is and not have to do anything to it. But let's check it out. Let's check it out and see what we can cancel. I've got one Pb solid here as a reactant, one lead Pb solid here as a product. That means we can cross it out. Again, we're just basically going to add down if you want to look at these as math reactions. In reaction A, I have two Cl2 gases, and in reaction B, I have one Cl2 gas. So this one is going to cancel with one of those, leaving you with just one on this side. That's all it cancels out. So if I write what's left on the reactant side, this is gone. So we have PbCl2 solid plus one Cl2 gas yields gone, gone. The only thing left on the product side is PbCl4 liquid, and then you compare again. Is this what we wanted? Yep, yep, yep. It's just like we wanted. So at that point, you're going to add your delta H's. So we're going to have negative 329.2 plus 359.4. So we have a delta H, an enthalpy change of 30.2 kilojoules, and that is your answer. Positive 30.2 kilojoules, and again, that would mean that this reaction is endothermic. Okay, now I'm going to leave number 3 so this video isn't too long. YouTube struggles with too long of videos uploaded, so I'll leave that one alone. I went over, but please do number 3 now if you haven't. I went over 4 in class. I'll go over 5 real quick, which hopefully I can get this video to upload. This is a 3-step. Okay, you've got hydrogen cyanide, highly poisonous, volatile liquid. It can be prepared by this reaction. Okay, but either this is too dangerous to be around or takes too long, so we can figure out the enthalpy change, whether it's exothermic or endothermic, by manipulating these 3 partial reactions. Okay, so I'll start with CH4. I'm looking for it. I see it here in reaction B. That's the only place it shows up. I need one of it as a reactant. I have one of it, but it's a product. So I need to take reaction B and flip it. So I'm going to rewrite reaction B. CH4 gas, methane gas, yields graphite, solid carbon, plus 2H2 gas. Okay, and obviously since I flipped this, I need to flip the delta H. Delta H now becomes positive 74.9 kilojoules when it was a negative. Okay, so CH4 is good. Now, NH3, the only place NH3 shows up, double checking, is in reaction A. Reaction A, I have 2 of it. I only need 1. And it's a product, I need it as a reactant. So I need to take reaction A and flip it and multiply by a half. Okay, so this is going to become NH3 gas when I multiply by half. yields a half N2 gas. Again, I had 1, so I had to multiply by a half. And this is a little tricky perhaps. Plus, I had 3 H2s. Half of that is 3 halves or 1.5 H2 gas. Okay, and again, the delta H now is going to become flipped, so it's positive because we flipped the reaction. And then 0.5 or a half times 91.8 gets you 45.9. So positive 45.9 kilojoules is your delta H there. So delta A is good, NH3 ammonia is good. Now I'm going to go to HCN. That is your poisonous hydrogen cyanide right there. Need it as a product, and I need 1 of it. The only place it shows up is in reaction C. It's a product, but I have too much. So again, I have to take this reaction and multiply everything by half. So no big deal, half H2 gas plus, I had 2 graphites, now it's just going to be 1 carbon graphite. Half 2 is 1, last time I checked. Whoops. Plus a half N2 gas. Yield you now half times 2, so 1 HCN gas. Okay. And of course, since I multiplied by half, I need a half of 270.3, which is 135.15 kilojoules. Now, we're going to do our canceling, make sure everything's good. Okay. Now, carbon graphite. I have it at 1 as a product in reaction B here. I have 1 as a reactant to the left of the arrow here, so I can cancel that out. Graphite's gone. Okay. Let's see, what else can we knock out here? Look at hydrogen gas, H2. On the product side, right side of the arrow, I've got 2 plus 3 over 2. So this is essentially 2 plus 1.5, so 3.5 H2s. Well, I have a half on the reactant side, so this half is going to knock out a half of this 3.5, okay, leaving you with essentially 3 H2s. Okay, so I'm going to write that down here. We've got 3 H2s once we combine that and that. Okay, let's see what else. Now, this was a plus sign. I got a little sloppy here. This is my arrow. So on the left side of the arrow, I've got a half N2. Well, on the right side of this arrow, as a product, I've got a half N2. So those are going to cancel off. N2 is gone. Okay. So now on the reactant side, what I have is 1 CH4 gas plus 1 NH3 gas. Those did not cancel with anything. Those are the only reactants that are left because these canceled. And then on the product side, I added those to get 3 H2 gases. And then, of course, my poisonous hydrogen cyanide, HCN. Okay, so if I compare, this looks exactly like this. We're all good. We're going to take our delta H's, 74.9 plus 45.9, that's 9, plus 135.15. We're going to add them together. If you want to get sig fig, you can only go to the nearest tenth. So I'd have to round this to 256.0 kilojoules. Obviously, an endothermic reaction is going to absorb heat. Okay, so hopefully by seeing those 3, you can now complete the rest of Hess's Law. Okay, and there's a worksheet on the table for you guys to do here in a minute after you watch the next video. Hope you have a great weekend. Thanks for watching.